By keenly confronting the enigmas that surround us, and by considering and analyzing the observations that I have made, I ended up in the domain of mathematics. Although I am absolutely without training in the exact sciences, I often seem to have more in common with mathematicians than with my fellow artists. M.C. Escher, born June 17, 1898, was a Dutch graphic artist known worldwide for his mathematically inspired woodcuts, lithographs, and mezzotints that feature impossible constructions, exploration of infinity, architecture, and tessellations of the Euclidean and the hyperbolic plane. Many of his pieces were drawn from unusual perspectives, thus creating enigmatic spatial effects. In his graphic art, he portrayed mathematical relationships among shapes, figures, and space. He explored repeating patterns of interlocking motifs using black and white to enhance different dimensions. Integrated into his prints were mirror images of cones, spheres, cubes, rings, and spirals. Although Escher did not have any formal mathematical training, his understanding of mathematics was largely visual and intuitive. M.C. Escher became fascinated with the regular division of the plane by employing a repeated tiling called tessellation. A tessellation, or tiling of the plane, is a collection of plane figures that fills the plane with no overlaps and no gaps. Throughout the Second World War, he vigorously pursued his hobby by drawing 62 of the 137 regular division drawings he would make in his lifetime. Escher's work had a strong mathematical component, and more than a few of the worlds which he drew are built around impossible objects, such as the Necker cube and the Penrose triangle. A long time ago, I chanced upon this domain of regular division of the plane in one of my wanderings. However, on the other side, I landed in a wilderness. I came to the open gate of mathematics. Sometimes I think I have covered the whole area, and then I suddenly discover a new path and experience fresh delights. Around 1956, Escher's interests changed again, taking regular division of the plane to the next level by representing infinity on a fixed, two-dimensional plane. He had put his designs onto a variety of three-dimensional objects, such as columns and spheres, again in an attempt to impart an endless perspective to his work. He later tried working with the concept of similarities, using identical motifs of diminishing size, arranged in a series of concentric circles. Escher used the Poincaré disk model of hyperbolic geometry for his circle limit patterns. In these models, Euclidean objects are used to represent objects in hyperbolic geometry. The points of hyperbolic geometry in this model are just the Euclidean points within a Euclidean bounding circle. In this way, one creates, as it were, a universe, a geometrical enclosure. If the progressive reduction in size radiates in all directions at an equal rate, then the limit becomes a circle. The hyperbolic lines are represented by circular arcs orthogonal to the bounding circle. The Poincaré disk model was appealing to Escher, since an infinitely repeating pattern could be shown in a bounded area, and shapes remain recognizable even for small copies of the motif. Escher was more interested in the Euclidean properties of the disk model than the fact that it could be interpreted as hyperbolic geometry. Escher's artwork is especially well liked by mathematicians and scientists who enjoy his use of polyhedra and geometric distortions. He continued to develop and enhance this field and produced many more prints using both circles and squares as the frames for his works. He also studied the mathematical concepts of topology and learned additional concepts of mathematics from the British mathematician Roger Penrose. From this knowledge, he created waterfall and up and down, featuring irregular perspectives similar to the concept of the Mobius strip. Escher's works covered a variety of subjects throughout his life. Over 150 colorful and recognizable works testify to Escher's ingenuity and vision. His art continues to amaze and wonder millions of people all over the world. In his work, we recognize his keen observation of the world around us and the expressions of his own fantasies. A world which is far away from our general perception of reality. A world of mathematics, a world of abstraction. But then, as always, we can make connections between this abstract world and the real world. M.C. Escher shows us that reality is wondrous, comprehensible, and fascinating.